In the name of God, the merciful, the compassionate, in this session we are going to practice ANSYS rocky simulation by simulating a simple motion of particles pouring through a helical way into a container. For this simulation, we are not going to inspect the physics in details. We're just trying to practice the setup of ANSYS rocky simulation to know what to do first, what to do the second, for the second step, and so on up to the end. To do this, we have to drag and drop a particle dynamics rocky simulation from here to the right part of the workbench window. Project schematic. Now we have an option to open design modeler and also discovery or space claim to design the geometry of the simulation, design the helical way or the container which we are trying to simulate the particles moving on, or we can just click on setup and open it without importing geometry in the geometry module, despite other modules such as static structural, transient structural, or dynamic explicit, and the others, which we have to firstly design the model in the geometry module, and during the second step it automatically moves to the setup module by updating. In this module ANSYS rocky, we have drawn our geometry in ANSYS in SolidWorks software. You can draw your geometry in any other softwares such as CATIA, the ANSYS SolidWorks Inventor, or any other CAD software, and then import it directly into the setup module. You see, I removed the geometry module by right-clicking and removing geometry module. Now I open setup Here you see the ANSYS rocky environment opens. We click here to open a workspace. Here we have nothing displayed here. That means that there has been no geometry imported into the ANSYS rocky environment. So we come here and see that in this tree we are looking at, there are some items such as modules, physics, materials, motion frames, geometries, particles, joints, contacts, SPH, inlets and outlets, CFD, even CFD coupling, and doing some CFD, having some CFD approaches, and also coupling with Fluent or other CFD modules that ANSYS has, and the solver, the setting that we have to set to mention that how to solve the problem. So you see here, I first go to physics item, and here I have to write down some physical characteristics of the simulation. The first item, the first tab is gravity. Gravity contains X direction, Y direction, Z direction, gravity start time and gravity stop time, which are to be evaluated through here. We have to write down some values here to know how to impose the gravity force on particles during the simulation, meaning that the ANSYS has to know how to impose gravitational force during the simulation on particles. The unit is shown here, which is meters per square second. The X direction is the acceleration. The X direction, Y direction, Z directions are X, Y, Z directions of the gravitational force acceleration. As the direction of the gravity force is in this direction, we choose Y direction here to write down -9.81 as the gravitational force acceleration imposing on particles during the simulation. The second item is momentum. Here, for momentum, we don't write anything for this simulation. Thermal means thermal properties that can be written down for thermal analysis and simulation, and also course grading, which we don't have to set for this simulation. We just set this first item, gravity, as it is a gravity simulation showing the motion of particles being forced by gravity of Earth. Materials. The second item is materials. There has been some default materials in ANSYS simulation showing let me say such as default belt. Belt is used for conveyors. There is some interesting there we have an interesting point that in ANSYS Rocky you can simply design and simulate a conveyor without wasting so much time, and you can have a good approximation of how your conveyor should be for particles. And then after the approximation, you can go in details with CAD softwares and finalize your design. Since this fact has been considered by ANSYS, in ANSYS Rocky module there has been default belt, which is referring to the belt of the conveyor, I think. Default boundary, the walls that particles are in contact with. In the default particles is characteristics of the particles that are moving during the simulation, such as bulk density with this unit of kilogram per meters, cubic meters, and also Young's modulus, which can be changed into gigapascal. And even Poisson's ratio can be written down here. So you see, not only you can create a solid material, but also you can create fluid materials in this materials module of ANSYS Rocky. This means that you can even simulate some fluid motions or fluid solid mixed motions or fluid particle mixed motions in ANSYS Rocky, which is very interesting and is very inventing manner that ANSYS producers have. Motion frames, because it helps the industry to find out something about mixers, conveyors, and etc. The second, the first item was physics, the second item was materials, the third item, motion frame, is the motion frame that the geometries would be considered to attend the simulation through, and we have to set them up here by right clicking and creating a motion frame. For the materials module, I forgot to emphasize that we are focusing on the default materials that have been here by default in ANSYS Rocky. For motion frames, we right click and create motion frame. One motion frame is created. There are several items that we can consider here. We just do some items to simulate a simple analysis in ANSYS. I'm sorry. Let me say we can change the name of the frame here. We just leave it as it is and don't change it. The second item, relative orientation method, angle and vector, would be the same as it was in default. It means that how the relative orientation would be in this frame. I'll display some items in details in next simulations, but for this simulation I just try to do something to show the setup procedure in ANSYS Rocky, which I have seen so so much less in YouTube videos. I hope it would help. For giving place, I set it to global item. And then leave the other settings unchanged. Geometries module. In geometries module, I can edit I can create a feeder conveyor, which is very interesting and very exciting for me. I like it so much. This is very nice that you can create a feed conveyor, create a receiving conveyor. Here is although it's a very simple conveyor, but it is a general and rough design of the conveyor you want, and it shows you how the overall length and sizes and height of the conveyor should be. The entire volume would be exported out of this ANSYS Rocky simulation. Then you can simulate other settings of your you can design other parameters and parts of your conveyor in other CAD softwares, and maybe then you can again import it into ANSYS Rocky to optimize your design. It is very nice and an engineering procedure that we have in ANSYS Rocky workbench. I have to mention that I'm using ANSYS 2025 R1. If you are using ANSYS earlier versions, there may be some changes. If you try, you can find them easily. So I can import valves from a part that I have made and saved it as an STL file here. When I click on the file and click open, a dialog window will be open. A window that includes the import unit. I set it to millimeter. Manual scale 1, then press OK to see what's happening and whether everything is okay or not. I'll drag and drop it here and see it's about 3.6 meters along X direction, X axis. It's about 5.2 meters along Z axis, something that I have designed just to do a simple analysis in ANSYS, and it is a symbol that we can do anything else in ANSYS Rocky. In next items, we will simulate conveyors in ANSYS to see how everything goes on. The second item, I can import a feeder conveyor by clicking on create feeder conveyor here, You see the video conveyor is appearing, and I will change the dimensions to show that we can change the dimensions and scales of the model we have imported in ANSYS Rocky very interestingly. I changed 3 meters length of the conveyor to 1, and also loading length into 1. You see changes that are happening here. And in the geometry tab, the second tab, orientation tab, you see I will change the settings here. To set the just a little something like that, a conveyor to locate it somewhere on top of the helical way which particles come through. You see, if I try to change horizontal offset, it will get move forward in the direction of x-axis. Then I will change it in built incline will be 0, vertical offset, horizontal offset, alignment angle can be changed, which is just set it as minus 90 here to align it with this opening. It's just a practicing of simulation. During the industry, something else would be simulated in details, and there is a professional model which is simulated there. But here we just try to set up a simple simulation. Out of plane offset means along z-axis offset. Along z-axis offset is correct, but along x-axis horizontal offset would be corrected to 1. I think, yes, that's right. It will be corrected to 1. And also, that's right, the second skirt board, we leave it unchanged. Feeder box, we leave it unchanged. Even we can change it into a little small feeder, but I prefer to leave it unchanged. Here in build motion. In build motion, there we have build speed. Build speed is something that I try to change it into 1 meters per second. Other settings would be unchanged during this simulation. Here in particles, we can define a particle by right-clicking on particles item and then selecting create particle option. One particle created that I have to set the settings of it. By default, the particle has a spherical shape, as you see. How did this window appear? I have to explain it. In the particle name, you can just write down stone particles as the name of this particle, and also I can say spherical stone particles. Stone spherical particles. Maybe it would be correct, more correct to say stone spherical particles. When I click on view button, I can see how the particle would be considered during the simulation, and how's the shape of the particle, how much is the diameter of the particle and the C. Here in porosity blank area, we write down 0.5 0.5, and then this item we have to write the size of the particle. We have just one size of the particle. We can have two sizes and the other sizes of the particle. Sleeve size type would be set on the sleeve size, and we just have one size particle, which is 50 millimeters in diameter, and the cumulative percentage is set on 100% cumulativity. Then the next step is to create particles. Write down 50. and I can change the shape of the particle with polyhedron, something like this. It's more natural. You have other settings other than sphere that we applied for the first material, such as spherocollision. You see how it changes. And also straight fiber just considered here, which is something nice here in ANSYS Rocky. So we set it to polyhedron for this simulation, and we see how is the dimension. The dimensions of this particle is set to, let me maximize the window. It is set to 0.0244 or 0.0244. Porosity would be set on 0.5. And the material would be set on default particles. Let me check whether the previous particle material is correct or not. Is correct. 2 is correct. 2. Yes. Here we check the collect joint data and also the collect contacts data item, and then we leave SPH settings such as Eulerian solution as it is, and step to the next item, inlets and outlets. Here we create a particle inlet. We describe that where is the inlet of the particles of our simulation. Here I choose the feed conveyor, which is placed here, and the particles are pouring into this space, and after that, and also as a result, as it is shown, the belt is placed here, so materials and particles are pouring on the conveyor belt and then transferring to the helical way and being under the effect of gravitation force pouring to the container. So what to do? We have to set the entry point as feed conveyor and just set which particles are following this rule. We set particle 1 and declare that declare that the mass flow rate considered for this particle would be about 3 tons per hour. For the second particle, we are simulating. I push the add button and set the second material as a stone spherical particle, change it into 3 tones per hour. This is the overall steps, the minimum steps that we have to do for simulating in ANSYS Rocky. With this procedure, the simulation starts. As it is a time-consuming procedure, I have simulated the particle movements and we'll see the results. Of course, we are looking at it, and I wanted at first to go to the previous simulation, but I prefer to do the live simulation, even if it is time consuming, to show you what's happening during this simulation. Some rules have not been set, such as rolling resistance or other settings. You see, spherical particles are coming down and some parts are pouring outside of the container. Because our conveyor is maybe not set in its real position, but it's not an important case. We just simulated something to see the particle movements. You see here, non-spherical particles are also pouring beside the spherical particles here. And we'll see the simulation. If I just uncheck the auto refresh button and simulate the simulation, I can see what's happening up to now, up to the time that everything has been solved. You see the motion of the particles here very nicely. And also, as the friction is not defined here, the particles would run out of the helical way. I don't know, maybe if I declare that there has been a friction coefficient, they would run out of the way or not. But as it is showing here, some of them are running out of the helical way. This means that it's better to show the speed of the particles here, translation speed, velocity translation, absolute speed. The colors that are shown here, and also the hues show that how much is the absolute velocity of particles. Every particle has a color that shows its velocity. Spherical particles get run out of the way, but maybe we have to declare that the friction coefficient is considered in our problem. Refreshing here updates the results into the animation bar. As you see, it's a time-consuming procedure. So we stop it and see the simulation up to here, and go to a second simulation with different sizes of particles that I have earlier worked on to see the results and the beauty of ANSYS Rocky. For this reason, I close this simulation, save the project, and open this setup, which is exactly set up with the procedure that I learned to you in the first item. Here, the simulation shows the particles coming down. Of course, these particles are more larger. You see some particles get out of the way, some particles come down. You can use mouse, holding mouse left click down and moving the mouse will rotate the geometry to see what's happening everywhere, and also right clicking will move the geometry from other positions of the display monitor. You see a particle just dropped down directly from the top conveyor without going through the way. And this is the case that if we designed in our real designation the place of the conveyor here, the place of the feeder here, we have to correct it or change it to avoid such a directly pouring particles, because something would happen in this container if they pour direct, like for example, or some procedures have to be considered in the way, during the way they're coming down. And you see, we can do everything in ANSYS Rocky. It's very nice and interesting for me, and I wish you enjoy. Particles are mounting on each other here. I've done several ANSYS simulations which are used in industry, such as fluent simulations, rocky simulation that I'm learning to do to you. I'm teaching to you, and also the static structural simulations, and also transient structural simulations, recently rigid dynamic simulations, and I have an open approach to projects, industry projects or mechanical engineering projects that you may have. For this reason, I write down my email address and WhatsApp number for you to get in touch and speak about the projects that you have to do or you wanted me to do for you. But of course, I have a manner of exactly systematic procedure during the work, meaning that I spent a lot of time to check everything, whether everything is accurately modeled, accurately declared for ANSYS or not, and I have an approach that leads into an accurate and exact result. So you can be sure about the results of my simulations. But in this case, we just simulated something in ANSYS Rocky to see how is a simulation in ANSYS Rocky. You see, materials here are mounting on each other. There has been an elasticity that when material hits the bottom of the container, it again moves upward and comes down in other regions of the container. It's the exact thing that happens during the real pouring procedure of particles. There are several particles that I will simulate in ANSYS Rocky in the future. But if you want something, you can keep in touch with me. You see the legend here? Let me drag it to the end. In the end, you can see particles here which have zero velocity, particles that are mounting on them and are getting slower and slower, reaching to zero velocity condition here. So this is the end of the simulation and end of this session. I wish you enjoy it, and Subscribe me for extra simulations that I will be doing in ANSYS Rocky. Have a good time and wish you keep in touch with me for your projects.